Hello, I'm Daniel Devine, and welcome today to our demonstration of the Control Panel Design Assistant, which sits in the TIA Selection Tool offline version. As you can see on the screen here, I'm the Integrated Control Panel Specialist for Siemens, and I'll be running through this little demonstration with you today. So, ICP, what is it? So, what we're offering our customers is a optimization of control panel building by supporting you from local experts, namely myself here in the UK. So for our UK customers, we're offering a free service, which is giving practical consulting on applications such as those for North American standards, EU directives, temperature rise, EMC compliance, and optimization of your engineering processes. So within this, today we're going to focus on easy entry into digitalization using our tools and data. And specifically today, we're going to use the Control Panel Design Assistant. So let's jump over to it now. Okay, here you can see our TIA selection tool. This is the offline version, and this is where the Control Panel Design Assistant sits. So at the end of this demonstration today, I will show you where to download this, if you don't already know, and show you where you can download some other useful um, documentation, such as white papers and reference manuals, all around control panel building. Okay, so from here, what I'm going to do, I'm going to go into the project view. Once we're in project view, I'm now going to navigate to the main circuit. Okay, here you can see we've got the option for an IEC in feed. We've also got the option for a US in feed. We will have a look at both today. First and foremost, let's go into the IEC in feed. Just click on it once, and you see a little in feed will appear here. Now, on the left-hand side, you can see these yellow exclamation marks. That just means that we're lacking information. We need to put information in here so that we can determine these devices. Okay, so from this page, there's a few ways of going about this. We can go up here to the Control Panel Design Assistant, and this little functionality will walk you through each step nicely. But today, I'm just going to guide you using the screen itself. Okay, so in here, load feeder, electrical load, we can just double click on it. It'll take me to the screen. So what's the type of load? Okay, is it a motor load? Is it a user-defined load? Or are we using a soft start? Okay, we're going to look at all three of these today. Okay, the motor direct online. This is for fixed speed motor starting, so we can look at some DOLs, reversing starters, and star delta. Okay, so let's go ahead and do that. What's the kilowatt rating of the motor? Let's put in a 0.37 kilowatt motor. Here you can see the current will populate. Now we've got on here advanced configuration and cable characteristics outside of the cabinet. What this tool is going to do essentially, it's going to be creating single line diagrams for us for our motor starters. But also what we're going to get today as part of this calculation is the cable dimensioning and the short circuit calculations done. So that's going to save you a lot of time, and it's also going to avoid you having to use multiple equations to achieve these calculations. Okay, so here we've got here advanced configuration. Let's have a quick look at that. So is this motor part of your resulting current calculation? Yes or no? So for example, rather than applying a diversity factor, we can go ahead and say, yes, this is part of the calculation. What's the efficiency class of the motor? What's the cable length? So I mentioned to you we're going to do cable calculations. This tool takes into consideration attenuation. So the further your motor is away from the panel, the lower the potential short circuit fault, and hence this will do this in the calculation for you. Minimum cross section of the cable, and then down here, cable characteristics outside of the cabinet. Again, number of loaded circuits. This can have a big impact on the derating of your cable, for example. The method of installation. Is it multi-core cables in a cable duct? Is it multi-core cables on an open cable tray? Again, this will all affect the factors on your cabling. So once we're happy with that, which this part is optional, we can now go across to the control devices. Okay, so What type of start is it? Is it a direct start, reversing start, star delta? Let's go for direct. What type of protection? Circuit breaker or fuse? And your overload, do you want it integrated in the motor circuit breaker, or do you want a separate thermal, electronic, or SIM code? Let's keep it integrated in the motor circuit breaker. Coordination type, 1 or 2. Control supply voltage, AC or DC. And obviously, control supply voltage. Let's go for 24 DC. Connection type, screw or spring. Let's have a look at spring. So now we're ready. Let's calculate. Here we go. We've now got a Siemens circuit breaker, contactor, cable dimensioning, and short circuit calculation done for you, all in a matter of seconds. Here on the left-hand side, you can see everything's gone green now. What's this? Accessories. Let's click in. Here, it's added our link module, spring type version between motor protection circuit breaker and contactor. This is unique to Siemens, this. Very, very handy and useful to use. It'll save a lot of time and wiring. Okay, what else? We can have a look at the contactor, for example. And we can also add further accessories if we needed to. Here you can see on the right-hand side, auxiliaries, surge suppression, covers, whatever. Let's go back now to our main circuit. Okay, quite easily, we can duplicate this. We can change the name of these from load feeder 2 to specific motor name, belt fan, whatever. Let's add a star delta. Again, double click. Motor direct online. Let's go for 7.5 kilowatt. We do go all the way up to 250. Let's go for 7.5. Same cable characteristics. Now we're going to drop this down and go for star delta. Symbols will change. We've now got a thermal overload. Again, DC 24. Let's just leave it at screw. Calculate. Again now, in a matter of seconds, we've got all our parts. So here's our circuit breaker. Let's just scroll across here a little bit so you can see. Here's our contactors and our overload. Cable dimensioning has gone slightly higher now because of the rating. We've got 2.5 mil cable. And again down here, IK max, IK min, we've got our short circuit calculations done. What else have we got? Let's look at accessories again. We've got our nice wiring kit for these. Perfect. This will save a lot of time wiring. We'll go back up to the main circuit. I just want to show you 2 more pieces of functionality, okay, which is the soft start and the user-defined load. Let's quickly look at a soft start. Double click in here. We'll drop this down to a soft start now. So let's configure the soft start. What's the rated power? Let's go for 15 kilowatt. Number of poles of the motor. Used service factor of the motor. As you can see, this is selected a Siemens motor. If you're using Siemens or not, it's fine. Let's scroll down. What's the load type? Okay. We can say we're using this on a pump, for example. You can see the torque on the right-hand side. Now, if we want to apply some application parameters, for example, current limiting, we can go ahead and change this as per we need. Cable characteristics again. Now let's go for the actual device. Okay, so do we want it with a circuit breaker or fuse? And again, 24 DC. Do we want it with screw or spring? Do we want the optional line contactor? Let's go with yeah. Okay, now let's calculate. Great. So we've got our motor circuit breaker, our contactor, and our soft starter. Brilliant. Here, unfortunately, at the minute, we don't have the cable dimensioning for the soft starter, but we do for the other pieces of it. Hopefully that will come soon. Now let's go back up to our main circuit. And we're just going to add one more load, a user-defined load. Okay, so we've got our two DOLs, star delta, soft start. Let's add, for example, a variable frequency drive. Double click in here. Going to add a user-defined load. We've got some options, a none or slightly inductive load, AC1, motors, VFD. We've got transformers, capacitor banks. We're going to add a motor VFD. 3-phase. Let's go, I don't know, 15 kilowatt again. Now go to the control devices. What do we want? Do we want a motor starter protector or a motor molded case circuit breaker? Let's go for the motor starter protector as defined by the load. We can change that if we need. Again, let's stick with the 24 DC. Now we calculate. Here we go. Now we've got our circuit breaker here for this load. 6mm cable. Okay, great. Let's go back to our main circuit. So now, let me just zoom out slightly so we can see it all. We've got our setup, okay? Also, here, main disconnect. So we've done a total current calculation of this setup. And as you can see here, it's the one thing that's still yellow. So let's go into the main disconnect. Okay, so we've automatically calculated the rated current to be 68.98. We can click here and add a manual, say 100 amp if we want. But if we're happy with the automatic calculation, let's go ahead. What type of device do we want? A molded case circuit breaker or a switch disconnector? Let's go for a molded case circuit breaker. What do you want, thermal or electronic? Stick with thermal. And then down here, do you want fixed thermal or adjustable, etc.? Number of poles, 3 or 4. Let's stick with 3. Calculate. You can see everything's green now. Up here we can see our main disconnect rated at 80 amp, 55 kA. Let's go back to the main circuit. It's starting to look complete now. Okay, so from here, just a bit of information then before we look at the US in feed. Information. So on each of my poles here, each of my branches, we've got all the calculation details behind this, okay? And also an area where we can download certificates, etc. What else can we do with all of this? Well, we can copy this image, is one thing. But other than that, let's scroll up and see what else we can do. Okay. Up here, project, we can actually export this straight into ePlan. Okay, really great functionality. I've seen it work, it's great. Okay, what else can we do? Well, we can print a complete project overview with title page, author properties, group load feeders, group information, all the device properties, all onto a nice PDF document that looks a little bit like this. So here we go. Here's our title page. I won't go through all of this just to show you what it's like. When it was created, we're going to do a project overview, the voltage in the system we were on, and here it breaks everything down for us, each individual load. And again, it'll go through all of the different calculation details for you. So really handy to have, and you can start using you can use this in your compliance documentation. All the calculation details are here, and this is the start of your technical file. Let's go back to the tool. So what else can we do here? Okay, planning sketches. Let's have a look at this functionality. Click in here. Here we can say what size of box we're going into. So we can change the height, the width, and then we go back to our products. What have we chosen? let's have a look here. All we have to do is just drag and drop our devices over into the panel or box. These will all be scaled to size, and we can have a little play with this and see what our panel is going to look like. What else can we do? Here in the order list, here we've got all of the products we now need. Okay, our link module, our modules for star delta, our link modules, all of the contactors, etc. And here all of the quantities. So from here we can export this onto an XLS, for example, or this is really handy here. Export information. Export into the Siemens CAX data tool. Now what does that do? Let's have a look. This is a really, really handy functionality. And again, we talk about technical files. This is going to help you produce your technical file. So this is what happens once we click on that button. Okay. Now we're going to select all of the products. Continue. What are we going to do next? Well, what information do we want? 2D data, 3D data, wiring diagrams, data sheets, manual operated instructions. So now I really am building my technical file. Continue. What language do we want it in? German or English? Continue. Here's all of the information we've requested. So we give our download a name and create the download. So what you will find, depending on how many products you've got, Siemens, this tool will go ahead and start collating that data for you. You don't need to do that. You will then get an email from Siemens with a link. Click on the link, and in there will be a zip file with all of the information you requested. It's really, really handy and makes compiling your technical document a lot quicker and easier than if you were to use a Siemens competitor or another manufacturer. Okay, so let's look at now the UL 508A functionality. So let's just get rid of this one. Now we're going to do a US in feed. Okay, so this is going to cater for UL 508A. Click into it. Now you can see the ANSI symbols. Here, quite importantly, are in feed. Let's double click in. So in North America, you're probably aware, we have two main systems, solidly grounded Y, corner grounded delta. Now, depending on which one of these we use, will dictate what control components we can use and what type of starters we can have. So let's look at that. Okay, we're going to go for a solidly grounded Y, 480 Y/277, as opposed to a corner grounded delta 480 volt system. Okay, so let's have a look. Let's go back to our main circuit. Now, again, we're going to look at our loads. So let's double click in here. We've got motor direct online or user-defined load. We're going to go with motor direct online. So now we see we talk about horsepower, full load currents, etc. as per the UL 508A. So we're going to say this is a 5 horsepower motor. And again, we need to input the service factor once we know that. Here, it calculates our FLC and FLA. And again, this tool is going to do a single line diagram. It's going to do our short circuit capability using the Siemens combination of motor protection circuit breaker, or combination motor controller as they call it in the States, and a contactor. Okay, and again, we're going to look at the cable dimensioning in American wire gauge. So advanced configuration again, like we did previously. Now let's go to our control devices. So direct start, yeah. Now this one here, this is what I talked about. So when we're looking at a corner grounded delta or a solidly grounded Y, we have some options here in terms of a motor starter. C, inverse times circuit breaker, contactor and overload relay. Self-protected combination motor controller contactor, or fuse and contactor. So F is the most common, but please note F is only available for a 480Y/277 system and cannot be used on a corner grounded delta. And this tool will take care of that for you. It will not allow you to select an F for a 480 volt system. But in this instance, we can. So let's go for it. F. Again, we can have DC 24, screw, we can change that if we need. Calculate. And now we've got it again, okay? We've got our motor circuit protector, or combination motor controller as they call it in UL 508A. And we've got our contactor, our American wire gauge now, AWT14, our electrical load, and we are happy. SCCR combined combination, giving you a value of 65 kA for this combination. Perfect. And just like we did previously, we can go ahead and build this system up. Yeah, let's have a look. Duplicate. And then we can go to the main disconnect again. This will be our feeder device. We want an inverse time circuit breaker. Perfect. Thermal or electronic. Calculate. And it's done it. Here we've got a 3VA5. So it's the Siemens UL489 device rated for the North American market. This will be our main feeder device. SCCR of 65 kA. Perfect. I hope you liked this demonstration. Now let's have a look at some other information where you can download this tool and other assets. This is the Siemens control panel webpage. You can access this at www.siemens.com/control panel. Okay, siemens.com/control panel. Once we are there, as you can see here from this webpage, there is a lot of information regarding control panels. Standardization, electrical equipment, recent topics, webinars. I'll look at the control panel design assistant, info center. So here again, you'll have lots of topics, UL, CE, control panels for the international market, EMC. So much information, okay? For me, the control panel info center is a great place to start. A few ways of accessing it. We can see it here. We can see it here. And we can also see it here, info center. Let's go there. Okay. In the info center, you've got multiple topics, okay? Lots of downloads, free downloads. Let's have a look at downloads here. TIA selection tool offline version. We can go ahead and download that. And we've got some other great tools for panel design. Also, we've got white papers, manuals, application examples, webinars available to watch, up and coming webinars and on demand, manuals. We've got some great reference manuals. Here's one for panels for North America. Here's one for IEC standards. A great place to start looking for information. So once again, let me thank you for watching my short video today demonstrating the Control Panel Design Assistant tool. Please, if you have any further questions, contact your local contact for Siemens control panels, which you can find on that web page I've just shown you. I am the expert here in the UK. Again, if you're a UK customer, please reach out. Thanks very much for your time. Goodbye.